Good morning, everybody. So today our topic is limit continuity and differentiability. It's a very important topic for 11th and 12th standard, okay? Because so many questions has been asked based on this. And this is the basics of differentiation, and differentiation is the basic of integration. So basically this you can say the root of the calculus. So today we will see very important topic, that is limit continuity and differentiability. Let's see. First I want to explain about this limit, then I'll go to continuity, then I'll go to differentiability. Okay, let's see. Suppose we have a function y equals to fx. Suppose we have a function y equals to fx. This is our x-axis, this is our y-axis. Okay. Now consider this point. I am taking any point on this curve. Okay. Suppose that point is x and fx. Okay. Let me draw it. Fine. Now see, suppose we are going along this curve to this point. We are approaching. Suppose this point is A. Here we have point P, and here we have point Q. Now the P point is moving to A, and Q point is also moving to A. Okay. It is moving in this path only, moving, and it is moving, and we are very close to A. And also Q is moving here, moving, very close to. Let me give the circle to represent the point. Now at this point, what will happen? The P is just left of A and Q is just right of A. Okay, this is called the limiting value of this function at this point. This is called left hand limit, and this is called right hand limit. Okay, this is the case where the function is defined at x. Suppose we may have undefined also, and also limit exists. Limit exists if left hand limit is equals to right hand limit is equals to the definite and finite. If these two cases are satisfied, then we say that the limit at that particular value of this in the domain of this function x exists. Left hand limit should be equals to right hand limit, and that should be a definite and finite real value. Okay, real value. Then we say we study the whole calculus as real only, as of now for real only, because complex is not there in our syllabus, so we will consider only the real functions only. Okay, this is the case where the function was defined at x. Here this will be equals to left hand limit. We also write like that, f of x minus, and right hand limit we write f of x plus. Also we can write it as limit x tends to x minus fx is equals to limit x tends to x plus fx. This is the way we can write the limit. Okay, these are the different ways. Now I will take one example in which the function is not defined. Let's see that example. Now see, suppose we have a function like this. This is y equals to fx. and the coordinate of this point is 2, 5. Okay, this is the point. Now see, we have to calculate the limit x tends to 2 fx. What is the value of it? Fine. See, if you see the graph of y equals to fx, the function is not defined at x equals to 2 because this is a hollow bubble, and by hollow bubble we mean that the function will not exist at this point. Okay. Now see, we have to calculate this limit, right? Means we have to calculate its left hand limit and right hand limit, and we will have to see whether that is coming constant, that is coming finite and real or not, and equal also. If that is not coming, the limit will not exist. Now see, the left hand limit here we can write limit x tends to 2 minus fx. Now see, when we are just left of a, the value of the function, this height will be 5 only, right? Because this is very small, so this height will be differing very small, so we can say this value as 5. Similarly, if we write the right hand limit, we can write x tends to 2 plus fx. Now see, if you are going from right hand side, okay, if you are going from right hand side, the value at 2, it will not exist, but at 2 plus, that is just right of a, the height, this height will be 5 only, right? Hence, although in this case the function was not defined at x equals to 2, but still the limiting value of this function is defined. And what is the value? Both are equal and defined, so this value will be equals to 5 here. Okay, this is the limit existing in such cases. Let's see the other example. Now see some other cases. Suppose we have a function like that. Y equals to fx, and the coordinate of this point I am giving 1, 3, and the coordinate here I am giving 1, 5, and we have to decide, we have to calculate limit x tends to a, fx is equals to what? This we have to calculate. See, this limit we have to calculate means we have to calculate left hand limit and right hand limit. Let's calculate it. So left hand limit we can write x tends to 1 minus f of x, and here we can write limit x tends to 1 plus f of x. Let's see. According to this, the function again is not defined at x equals to 1 because these two are hollow bubbles. Okay, now see, fx we have 1 minus. If you are going from left hand side, just left of a, just left of this straight line, what is the height we will get? This height, that will be equal to 3 only. So left hand limit is 3. Now approach a from right hand side. So along this curve, so here we will come again, here not defined. If you go little right, the function value will come here. And what is this height? 5. Right? So here you can say left hand limit is 3, right hand limit is 5, but the limit at x equals tends to 1 as fx, it will not exist. Hence, this limit does not exist. Understood? The limit will not exist. Fine? This is how we understand the existence of limit. Let's take one theoretical example. Now see, suppose the question is there is a function fx is equals to mod x, if x is greater than 0, is equals to 1 whenever x is less than equals to 0. And we have to calculate limit x tends to 0 fx is equals to what? This we have to calculate. Fine. See. Let's calculate left hand limit, right hand limit. Okay. So left hand limit will be limit x tends to 0 minus fx. Okay, that is limit x tends to 0 minus. Now see here x tends to 0 minus. What does it mean? X is just less than 0. Right? Here x is just less than 0. Whenever x is less than 0, which definition we have? 1. So what will be the value of fx here? 1. And this limit is 1. Let's calculate the right hand limit. X tends to 0 plus fx. Now see, here the x is just greater than 0. Whenever the x is just greater than 0, we have this definition. So here the fx we will replace by mod x. Now see, x is just greater than 0. And if you put this value here, you will get 0 mod, that is 0. Here left hand limit is not equals to right hand limit, hence the limit does not exist. Okay, so limit does not exist. Fine. Let's see next. Now see, suppose we have fx equals limit fx equals 1 by x. Find limit x tends to 0 fx. This equals to what? This we have to calculate. Let's see. Let's first calculate left hand limit. The left hand limit will be limit x tends to 0 minus fx. Limit x tends to 0 minus. Now see, what is the fx given here? 1 by x only. Keep 1 by x. Now see, denominator is tends to 0 minus, right? That's just less than 0. So 1 by 0 it tends to infinity. So with negative sign it will tends to minus infinity. Are we finding a definite real number? No. So here left hand limit does not exist. So left hand limit does not exist because it's not a finite value. Similarly, we can calculate here only we can say that this limit does not exist. But let's calculate the right hand limit. Right hand limit will be limit x tends to 0 plus fx. Okay, limit x tends to 0 plus 1 by x. Now see here, x is tends to 0 plus. It's a very small quantity which is greater than 0. So this will tends to plus infinity. And also right hand limit does not exist. Okay, right hand limit does not exist. Obviously here left hand limit, right hand. If you draw the graph of it, you will get the graph like that. This is the function y equals to 1 by x. Now see, this is 0, right? Now if you are coming from left side, this, it will keep on going up to negative infinity. Here from right hand side, if you approach, it is keep on going up to plus infinity, minus infinity. You can see this limit will not exist at x equals to 0. Fine. That is the existence of limit. Okay. Let's see next. So that was regarding the existence of limit. Okay. Now we will see the continuity of a function. Let's see. It is related to the limit. Okay. The continuity is related to our existence of limit. That's why I first taught the existence of limit. Now see the continuity of a function. See, the same way I will explain. Suppose y equals to fx is a function and we are taking a point here a and f of a. Okay, a function is called continuous at x equals to a. We can write a function is called continuous at x equals to a if left hand limit is equals to right hand limit is equals to the value of function at that x, and that should be real and finite. If this condition is being satisfied, then we say that the function will be continuous at x equals to a. In other terms, we can write f of x minus equals to f of x equals to f of x plus, where x belongs to domain of this function. We will talk continuity in the domain of the function only, right? Because if the points we are taking which is outside the domain, that is of no use and we don't have to consider those points. So this is the condition for a function to be continuous. Okay, left hand limit should be equals to right hand limit, and that should be equals to the value of that function at that point. Then we say that the function is continuous at that point. Okay, and if any suppose the domain of the function is from a to b, if the function is continuous from a to b, then we say that the function is continuous in the domain a to b. Okay, let's see more examples on it, then we will understand. Here if we see, this function is continuous because left hand limit, right hand limit and this all are only fa only, right? The height is same only, right? This height is f of a, f of a, f of a.